Hello there. I think it's time to start. So my name is Jose Barreto. I'm a principal program manager with the File Server and Clustering team. And the idea with this talk is we're going to talk about our file server solution for the private cloud with an emphasis in networking, right? So I like to position this in the context of a solution that we're building based on a full stack of Microsoft technologies. But I'm going to give you a little bit of an overview, kind of stepping back and looking at what we are trying to accomplish. And then we're going to dive into a couple of different technologies. One is SMB Multichannel. The other one is SMB Direct, which are some key capabilities in terms of networking that we can deliver using the Microsoft File Server and SMB 3.0. And then we're going to dive a little bit into end-to-end configurations. Look at how do you build these things as entire systems, and making sure that you have the right guidance to go ahead and deploy these solutions in highly available, fault-tolerant, continuously available, if you like, configurations. Last but not least, I'm going to try to go over a few of what I call issues, causes, and solutions, which is like frequently making mistakes, right? If you're deploying this and you're just kind of saying, oh, I'm just go ahead and do it, there are a few mistakes that you always make if you're not being careful, right? And we want to avoid that. We want to tell you up front the things that you should be taking care of, okay? And then we'll close with Q&A. Scenario overview. So let me give you an idea where I come from. So today, if you're thinking storage, there are many different types of solutions that you can have. You have, of course, our private cloud solutions, our hybrid solutions, and our public cloud solutions. And if you watched the keynote, you saw that we talked a lot about Microsoft Azure and how it's delivering on storage. And there are a number of sessions here covering that, not this one. We also have a hybrid with Storage Simple. So if you know about Storage Simple, a recent acquisition, fairly recent, in the area of storage, where we can do hybrid on-premise and then also extend to the cloud with Azure. This is actually being shown in the Tech Expo area. Very interesting solution, not what I'm talking about here. What I'm talking about is the first two, private cloud, either with a partner storage solution or with the Microsoft software-defined storage, right? So when I'm talking about private cloud with partner solutions, I'm talking about having Hyper-V connected to a SAN or a NAS solution from a third party. You know them all. There's a number of partners that we have that deliver storage solutions, either through iSCSI, through Fiber Channel, and now also with SMB as well. And some of what I'm talking here will apply to those solutions when using SMB, okay? Specific implementations of SMB Multichannel, SMB Direct might vary, but what I'm going to focus most here is in the private cloud solution with the Microsoft full stack. Windows, SMB, storage spaces, the scale-out file server. This is what it looks like. Even in that area, there are many different ways that you can do things. And we could be here all day long talking about all the different permutations of things that you can do. I'm going to focus on what we call this specific model that we use a lot. There's a Hyper-V cluster. There is a storage cluster. They're separate clusters. We call that disaggregated, right? The other thing is we are using standard industry servers, storage, networking. So you're building this out of components that you can buy, and that you can buy at a reasonable cost, right? So there are no surprises you should have here from a hardware perspective. We try to think that we are at the leading edge of this, but you don't need any special hardware. It's servers, as you know, how to deploy them, networks, the way that you commonly deploy them, and SAS connections to JBODs, which is fairly common, and shared SAS storage in the back. Okay? Overall, this solution tends to provide lower cost than other solutions. Now, within that stack, you saw the stack, right? You saw all the layers. I'm not going to talk too much about the Hyper-V side of things, or even too much about the actual bare bones. I'm going to focus on the middle of that stack where you have the scale-out file server. And of course, I'm going to talk about the interactions going up and down, but it bears an introduction. So back in 2011, if you went to Microsoft, say, hey, I have a file server. What can I do with it? We would talk to you about storing Office documents, Word, PowerPoint, Excel. And if you asked about things like, can I store a running server workload on the file server, we would not say that would be cool, right? Why? Because back then we used the version 2 of the SMB protocol, which is focused on what we call information worker scenarios. Now, with 2012, to be honest, we started that journey internally much earlier than 2012, but we opened it to the world in 2011 at the Build conference, the first of the Build conferences. And we explained how we actually evolved the protocol to the new version 3, and how we were delivering on things like the ability to transparent failover. So you have 2 file server cluster nodes. You're talking to cluster node 1. That cluster node 1 dies. You pull the power off that, or you do something weird and you just lose the connectivity to that server. We will transparently move the running workload to another node in the cluster. And if you're running Hyper-V or SQL, it will just continue to run, and you just have an I/O that takes a little bit too long. That's still something very unique to what SMB3 does. If you look at other protocols out there, typically it would take a timeout to even figure out that something is going bad. We introduce things like Witness that actually tells you when these things are happening before you even time out on TCP. So very, very interesting solution. Same thing for scale-out. In the past, if you had 2 cluster nodes running file servers, only one of them would actually be running that file share. The other ones would be there kind of waiting for something to happen. With SMB3 and the scale-out file server, we can now have 2, 3, 4, up to 8 nodes in a cluster, all serving the same file share. And you can talk to any of them, right? We delivered on SMB encryption, a solution for backup, extensive PowerShell support, VMM support. But really, the 2 things that I wanted to focus this talk on today would be SMB Multichannel and SMB Direct. Okay? These are technologies that are SMB technologies, but they are directly related to networking. Let's start with SMB Multichannel. So SMB Multichannel essentially is the ability of, when having multiple network interfaces, multiple NICs connected to a server, we can actually leverage them both at the same time. So 2, 3, 4. One server here, another server there, 4 NICs on each. We actually engage all 4. So if you're accessing a share over those conditions, we effectively create multiple connections, one for each NIC. No teaming required, right? No special requirements other than the fact that you have the NICs on both sides and that they can talk to each other, okay? One of the things that we also did was make that extremely fault tolerant, meaning that if you have those 4 NICs and I drop one, we will just continue to work with the 3 that remain. And whatever work was queued in the one that failed gets re-queued on the other NICs. Also transparent. More importantly, if that 4th NIC comes back up, SMB will also detect that and will re-engage that fourth channel. In fact, the demo that we did was kind of a funny one we did in the Storage Developers Conference back in 2011. We had a machine that had 2 1 gig NICs and a few high-speed RDMA NICs. And we start the demo showing, hey, look, we have 2 1 gig NICs we're aggregating. And people were like, oh, that's great. And then we added the high-speed NIC, and it, while running, switched to that faster NIC. And then we added another faster NIC, and then starting doing 2 times the faster NIC speed. So, and then we go and pull that back, and you can go up and down. And the reason we do this is because networks, if you have a lot of networking infrastructure, it is possible that something might fail. Human error, problem with a switch. So if you do it right, you can actually be fairly tolerant to failure, and you get the aggregated throughput when you have it. Few cases. So simple case, I have a 10 gig NIC. That's an interesting one. Just one 10 gig NIC. Can multi-channel do anything for me? Actually, it can. When you have a 10 gig NIC and you're trying to do a lot of small I/O over that NIC, what sometimes happens is what you're seeing there. One of the CPU cores will get very busy, and the other cores won't be busy at all. Why is that? That is because before we had multi-channel, SMB will create one TCP connection, and that was it. Then, with the introduction of multi-channel, what we do is we detect that that NIC has a capability called receive side scaling, or RSS, which means that it can actually engage multiple cores if you only give it the chance to go there. So with multiple TCP connections, we actually now engage multiple cores. And you know that machines are not getting faster individual cores. What's happening recently is that you're getting more cores that are fairly the same as we had 2-3 years ago, right? And this way we can leverage that better. Now, notice one thing. You don't have to change your configuration. SMB will automatically detect that you have RSS and will automatically engage the additional TCP connections. You don't need to do anything. Now, let's say you have 2 of those 10 gig NICs. What's going to happen? Not only we're going to detect that they can each have multiple connections, but we know that they are both going to the same place. So in fact, if I have a 10 gig RSS capable NIC, I will have 8 parallel TCP connections. And that directly relates to having the ability to actually go and use 2 10 gig NICs and deliver 20 gigabits of throughput. If you have a non-RSS capable NIC, and honestly these days these are fewer and fewer because what's happening is RSS is like a basic capability now for most server NICs. You'll find those only in sometimes desktop class NICs that they don't have RSS, and the likelihood of them being 10 gigs very low. But even if you do, we use them both, 1 connection per NIC. All right, and then way back when, we proved that this works, and we delivered on making transfers between machines that use 4 times 10 gig and achieving the near full line rate on these NICs just by engaging multi-channel and making the 4 NICs engage at the same time. In fact, the problem I have is someone came over here talking, yeah, you were talking about, I have 4 NICs, and I only intended to use 2 of them with multi-channel, just multi-channel engage them all. I say, yeah, that's the default behavior, because we wanted that to just discover and just go and engage. And there are ways, there's something called SMB multi-channel constraints, where you can tell multi-channel not to use them all, but by default, we will absolutely grab all the NICs that will give you connectivity between your client and your server, between your Hyper-V host and your file server host. Yes? Yeah, that's the question repeating here is the DNS, related to how DNS is behaving, right? One thing that I would say is multi-channel does not rely on individual DNS configurations or how paths are normally discovered on the network. When multi-channel does its thing, all you need to know is that you're here, you want to talk to a machine there. Then once I establish an initial connection, through the SMB protocol, the client asks the server saying, hey, give me a full list of your network interfaces. And then through the protocol, it gets the response and engages additional NICs. So even if you do //10.1.1.1 / something, you specify a IP address, single IP, we will still talk to it and discover that there's a 10.2.2 and a 192.168 or something else. And we will engage on those unless you establish constraints. So it is a very intelligent protocol. And I think it's fairly unique. I don't think that any other protocol has this level of discovery of additional network paths. Maybe not, but maybe you can point some to me. But another thing that we do look at is teaming. So when you have teamed interfaces, we treat those as RSS-capable interfaces because effectively what we're saying is there are multiple NICs behind that NIC that I'm seeing, so it will be useful to engage with multiple different connections. So for each teamed interface, we'll create 4 connections as well. And if you understand how teaming works, you will know that having more TCP connections will give teaming the ability to aggregate the throughput from the multiple NICs underneath, and will also give you your best behavior on this environment. So that's why we do this. We engage multiple cores, we get more bandwidth out of it. Last but not least, RDMA-capable interfaces. So we have now this new class of NICs that I'm going to talk about a little bit further, which are capable of doing a type of transfer that doesn't rely on TCP/IP. So there's a special mode where they can transfer data between them. The way we discover those is through multi-channel. So we will talk through regular TCP/IP to the other side, and then when we have this exchange saying, hey, what NICs do you have? Well, I have these 4. By the way, 2 of them are RDMA capable. And through that interaction, we'll discover that, and we will switch to that new RDMA mode automatically. So multi-channel is also how we discover that there are these specially capable network interfaces out there and that we can engage them, and we will. For RDMA NICs, we do 2 connections per NIC. That usually is enough instead of 4, right? Because these NICs are very capable, and the way they work, you'll see later, is very efficient. So that is it for multi-channel. And I wanted to actually switch over here, if you will, to a quick demo. I'll switch the monitor in a moment. And I wanted to just explain to you a few things and to let you know that it's important when you're dealing with multi-channel to understand the interaction between multi-channel and clustering. As you will see later, clustering is how we deploy these things. We want these to be highly available. So every time we're deploying these solutions, not only you have networks, but you also have clusters associated with those. And there's a relationship there. So in my example, I have a 3-node file server cluster, which you can see here. So I have S1, S2, and S3. I also have a scale-out file server cluster. It's important. Because I have a scale-out file server cluster, you will see that all 3 nodes are available to do work for me, right? Now, one thing you notice, if you're familiar with clustering from other times, you will see that I have no IP address resources here. Remember the time when we had to create a file server cluster and we had to have a disk resource and you had to have an IP address resource, and that IP address would move to the node, and none of this here. The way this works is this name, Jose-SO, will be the name for my clustered file server cluster, my cluster resource. And that will have all the IP addresses from all the nodes in that cluster. We don't create special ones for this. I'll get more into it later. Then I'm going to look at my disks. Interestingly enough, I have 4 cluster disks here. One is a witness, which I don't really need because I have 3 nodes, but it never hurts. You know that when we are in this mode that we will treat even and odd nodes now, odd number of nodes now differently. So when we have the need for a witness, we'll engage the witness. When we don't need, we won't, right? So there's no harm in having the witness there. The other thing that you'll notice is that I have 3 volumes. And these 3 volumes are going to different nodes. You notice that? This one is S2, this one is S1, this one is S3. Is that a coincidence? Did I do this manually? No. Cluster, now, when you're using cluster shared volumes, which are these volumes that all nodes can act on, now naturally spreads the volumes around the nodes. If I had 6 volumes, I would have 2 per node, guaranteed, right? And why is that important? That is important because now we have a certain affinity between the node that owns that volume and the clients coming in. I can actually redirect them to the right node, to the best node, to do work there. And I have 2 cluster networks. And I'm using all for cluster and client traffic. Remember the days when we recommended that you have 5 different networks? You remember what the 5 would be for? There would be 1 for storage, 1 for management, 1 for cluster communication, 1 for migration. These days, you can actually just have 2 for fault tolerance, and you share that to do other things, like cluster communication. These days, we're much less strict. And if you think about it long enough, we have much more capable networks these days anyway, right? Anyway, I have 2, and they're both being used for client access. Now, if you know me, you know that I use GUIs, but I really like PowerShell. So let's switch to PowerShell. So this is a little commandlet, a set of commandlets to look at the same information that we were looking at before. So what are the nodes? What are the networks? What are the cluster resources? And what are my cluster shared volumes? So same kind of information if you look at it, right? So these are my 3 nodes, my 2 networks. I still have a cluster IP address because of the cluster resource, which is a traditional, the cluster group, if you will. The cluster has a name. And then I have here my scale-out file server. And one thing that you didn't see before, the distributed network name. This distributed network name is the resource that registers the name Jose-SO to all the IP address of all the nodes in the cluster. So far, so good? Let's dig a little deeper. What I'm going now is looking at each individual node of the cluster and querying for IP addresses. So on the first node, I have 1. I'll ignore the 10.1. I'll speak just of the last 2 bytes, right? So I have 1.2, 2.2, 1.3, 2.3, 1.4, 2.4. So I have 2 networks, 3 nodes in the cluster. You notice the 100 address there? Who knows what that is? That's the IP address of the cluster group, the cluster name resource. It's always there. You can safely ignore it for this. Now, the important piece here is looking at if I do a resolve DNS name for the name of the cluster, which is the equivalent of doing an NS lookup if you're old school, right? That shows 6 distinct addresses, which are the 2 nodes, sorry, the 3 nodes and the 2 addresses on each one. So effectively, when a client says, I want to access a share that's // something, it will look at one of these 6 addresses. One of them, round robin, right? Then after I establish the communication with that specific IP, I'm going to go and query which other IPs on that node exist, and then I'll engage the additional ones. That make sense? Now, there's another thing that's important, which is the fact that we have what we call scope names. In cluster, when you create that cluster resource, we create cluster resources for each individual file server. I only have one here. And then it gets associated with the IP address. So you will see that for the -SO, I have 2 addresses on one node, 2 on the other node, 2 on the other node. For the Jose-S, which is the name of the cluster, I have the 100 IP address, as we talked before. And then there are these weird FE80 addresses. Anyone knows what those are for? Those are IPv6 addresses, but what are they used for in this case? This is the scope for internode cluster communication. So if you remember what we said when we started using SMB and clusters together, the communication between nodes in a cluster actually happens through SMB. So if you go to a node and you need to redirect traffic to another node, we create these connections between nodes in the cluster. They are SMB-based connections, and those are the names used for it. Too deep? I'll bring it back up. So I did a little access. I just listed the directory on share 1, share 2, and share 3. So just scroll up a bit. So here's listing share 1, listing share 2, listing share 3. By doing that, I create these connections, right? The moment I start the access, I create the connection to the share. And you can actually see the connection in 2 different ways. One is by using the SMB, the get SMB connection, which is going to say, hey, I'm talking to share 1, share 2, and share 3. I have the name of the protocol, I have the access, and I have the server name that I'm using. And you see that I have my 4 different connections, and I have 1 IP address for each. And you might say, hey, Jose, you said if these network interfaces are RSS capable, that I will have 4 connections per IP, and I only have 1 connection per IP. See here? I'm only using my 10.1.1 local address going to the node 2, 3, and 4. Why not more? Well, it is right to list only the ports that are 445. That's the SMB port. And we are only using 1 connection per share. So I'm using all 3 nodes because it's scaling out, right? It's spreading across. But I am not engaging more than 1 TCP connection. Why is that? Well, that's fairly simple. SMB will trigger multi-channel when there's activity. So if you don't read or write anything, multi-channel won't engage. So I'm going to go and do some I/O, and then I'll list again. And now you're going to see that I have connection from 1.5 to 1.2, 1.5 to 1.2, 1.5 to 1.2, 1.5 to 1.2. 4 connections per pair. Then 1.5 to 1.3, then 1.5 to 1.4, then 2.5, then, so total, 3 different servers, 2 network interfaces, 4 connections per, right? And I wanted to show you this because there's a lot that happens under the covers when we're doing these things. And it's kind of hard to see. So I promise I'll post the script and the output to the blog so you can inspect that a little in more detail. But you will see that there's a lot of what we're doing here that happens under the covers when we automatically establish those connections. Most interesting thing that we introduced in 2012, in my opinion, maybe because I worked on it, is SMB Direct. Right? SMB Direct was effectively us looking at the technology we had, and who are we kidding? We're comparing ourselves to storage, to high-end storage. And if you're trying to do this, we can do the multipathing thing, we can do the backup thing, we can work on performance, we can do all these things. But there was one thing that high-end storage used called fiber channel, which we couldn't match with regular TCP/IP. And what we did, we looked at high-performance computing, which had these special network interfaces out there for some time now. And we decided that the only way that we would achieve these high level of performance was by using this technology. And it was such an interesting bet. It's called RDMA. RDMA stands for Remote Direct Memory Access, which means that one machine can directly access the memory in another machine if the NICs are wired properly. So the NICs kind of function as a bridge between the two systems, and I can effectively say, I want to write this data to the memory of the other machine. And I deliver that to my NIC here, and the NIC talks to the other NIC and puts in the memory of the other system without the OS or the main CPU doing anything. So it's NIC to NIC automation right there. Yes? When I talk to the other side, the question is, when you're doing this, there's no network interaction on the OS layer. No. Initial negotiation, when I'm negotiating multi-channel, happens over TCP/IP as usual, right? We do name resolution, we do the regular thing. The moment we decide to, quote unquote, go RDMA, we will actually stop using the TCP/IP network on Windows. We're actually asking the NIC to do the work. And effectively, there are different ways that NICs do this. We don't care how they do it. If you put like a message analyzer solution or one of these network traffic capture tools, the moment we go RDMA, there's silence, right? It's another mechanism altogether. So we have on the SMB client, on the SMB server now, this different stack that we call the NDKPI, the Network Direct Kernel Mode Provider Interface, which is effectively a very thin layer that allows us on the SMB stack to talk straight to a NIC that has these capabilities, right? What does it give us? Extremely low latency, extremely high throughput. And we can do what people call zero copy, meaning that if I want to read something into memory, it actually grabs the data and drops it right where I want it, as opposed to the regular stack, which means I want to send this to you, then I take the memory, I slice into small pieces, copy that over to other buffers, then I send piece by piece. On the other side, I go and assemble each piece, then I copy over into the other buffer until I reassemble the entire package. With this, I can get an 8 megabyte data chunk, and I say, drop it over there in the right place. And it goes from one network interface to the other, right into the right place. No additional copies of buffers required, right? That's very important. And yes, the OS and the TCP/IP stack are totally bypassed, yes. Does it work on a traditional Ethernet switch? Now you're asking about details, which is good. I'm going to go there. There are 3 different technologies that implement RDMA that we support. One is called InfiniBand. InfiniBand has nothing to do with Ethernet. We support it. They simulate TCP/IP, but underneath the infrastructure is totally different. Different kind of switch, different kind of NIC. You can do that. The other option is RoCE. RoCE is RDMA over Converged Ethernet. That means that the NICs talk Ethernet to each other directly. Not the Windows stack, but the NICs themselves talk Ethernet to each other. The third option is iWarp, which is RDMA over TCP/IP. So the conversation between the NICs is over TCP/IP, which means not the Windows TCP/IP, but inside the NIC, there's a little TCP/IP stack that talks to the other side. That make sense? Any of the three work, we don't mind. And we ship a few of these drivers in box. More to come. So how does this work? We leverage these NICs, and we automatically engage them if we detect them. So remember when you talk about multi-channel? If we talk to the other side, and the other side says, yes, I can do RDMA, we'll switch to RDMA. We'll try it. If RDMA works, we're good. We stop using TCP/IP completely, and we start using RDMA. If at any moment there's any problem with RDMA, what do? We fall back to TCP/IP. Right? That's how the stack works. Your application, your Hyper-V, SQL, whatever is on top, doesn't know it's using RDMA. It will feel the effects of RDMA, but it can't tell. You're still doing / server name / share name, same as usual. Okay? The commands that I showed before, they will all continue to work. You can do name lookups. These NICs also have IP addresses the same way that we had before. The only thing that won't work is the GetNet TCP connection. Once we engage RDMA, we'll return nothing, because at that point, we don't, it will return just the one that we initially created, but it's not even in use anymore, right? You won't see these RDMA. There's actually a new command just to look at the RDMA stuff. Important thing, application doesn't change. The decision to go RDMA is a runtime decision. It's after we connect, and we find out that there is and make the switch. In fact, if you're doing a lot of work, the first few transfers might actually happen over TCP/IP while we prepare the RDMA stack and switch over to it. So if you start sending a lot of data, you might see that some of the data goes over TCP/IP, then disappears, right? And we're now doing RDMA. For SQL and Hyper-V, it's very rare to see that. Why? Because when Hyper-V boots up and starting VMs, it will start that connection. It will never let go of that connection until you shut down the machine. And so very early in the process, Hyper-V is accessing that thing. SQL, same. SQL service will very early on start opening files to do database activities, and it will never let go of those files until you shut it down, right? So that opportunity to observe the negotiation is a tiny opportunity at the beginning of the day when you boot the server. And if you don't reboot your servers ever, you will stay there all day long, all month long. Who knows how long? There are three favors, as I mentioned. And here I'm in a bind because people come to me and say, hey, which RDMA is better? Is it InfiniBand or Rocky or iWarp? And I will abstain from having an opinion, because my partners will, I'm bound to leave someone unhappy there. But I will tell you a few things. The first, there is non-RDMA. Then we have iWarp, then Rocky, then InfiniBand. And I outline a few pros and cons. When we started this a while back, some of these technologies could only do 10 gig. Now pretty much everyone can do 40 gig when they're doing RDMA. And we are going to start to see higher, so we can go up to 56 with InfiniBand right now. And people are talking about 100 gig already. And when we reach 100 gig, it's going to be fun. Because honestly, today, at 10 gig, RDMA is something that will help with reducing CPU utilization. But with today's machines, we can do a pretty good job at 10 gig without RDMA. We can do a lot of work, and it works fine. At 40, it starts to get really hard to reach the full ability of the network without leveraging a technology like RDMA. Right? And it starts to become more dramatic. If you do things that are large I/O, memory-to-memory transfers, like live migration of VMs, the difference is dramatic between RDMA and non-RDMA. When we reach 100 gigs, I think people won't even discuss it anymore. Because at 100 gig, if you're actually doing 100 gigabits per second that you slice and put down the TCP/IP stack and then reassemble on the other end, do you know how big those TCP/IP packets are? They're not that big at all. Even with jumbo frames, they're still just a few K, right? We're talking about transferring megabytes at a time here. So it's a dramatic difference. And when we reach 100 gig, it will be commonplace. We see more and more of this on the horizon. Yes? What about packet loss? Yes, some of these technologies, more specifically Rocky, has an issue with not having TCP/IP in the mix and not having the recovery mechanisms, but we leverage other technologies. So when you use Rocky, we use something called priority flow control, which takes care of that, right? So it's a solved problem. Fiber channel also went Ethernet, right? FCOE leverages the same technology that we use for Rocky. Same, very, very similar. I'll give you a few examples of cards that are very common out there. The Mellanox Connect X3 Pro, which is a very, very interesting card. It can do InfiniBand or 40 gig Ethernet. It can also do 10 gig. And we've done a lot of work with that card. I highly recommend it. We also have the Chelsea T5 cards. These are iWarp 40 gig. They also have a 10 gig line and models that go either way. A few of these cards are dual ported, right? And more of those, like those, are available. I have a few references there. Jose, would you use one or the other? I welcome them both. How do you set it up? So each one of these technologies, as I mentioned, you pretty much put the NIC in, update the drivers, set an IP address, and start using. That's what you would expect, right? Each one of them has a little quirk, and I can go over some of these things so you're aware. And some command lists that I showed there, get net adapter to get adapter information, get net adapter RDMA to get RDMA specific information for that NIC, and a few of the SMB specific things. One important thing you want to know is if SMB is recognizing that NIC as RDMA capable, so we have that. And then, as I showed in the demo, get SMB connection and get SMB multi-channel connection to see if you are connecting, if you're at the right level of protocol, and if multi-channel is engaged, right? Very similar to what we do with non-RDMA, by the way, same thing. We have specific performance counters, so you can monitor things. One of the most common things that people ask me is, hey, how do I know that RDMA is working? Because it's just the same thing happening. It's like, first of all, you should notice that your CPU utilization will drop. But until you have a high load on the system, you might not look. So performance counters are a good way to do it. PowerShell is a good way to do it. Yes? Say again? If I understand it, you're talking about the way the test manager shows this. Test manager won't show RDMA capability. It might actually look like you're not doing anything. So you should go to perfmon and look at the RDMA counters. If you go to perfmon and look at the TCP counters, you also look at the system and say, hey, there's nothing happening here. So that's why I listed the SMB specific shares. So if you look at the SMB counters, you see both. In terms of InfiniBand, we have a number of interesting things there. The most important thing here is, first of all, it works. Although it's InfiniBand, it has an IP stack as well. So no big deal. It feels like a regular NIC. The other thing, you need a subnet manager. We highly recommend that you use the subnet manager in the switch itself. If not, if you have one of those low-end switches that doesn't have a subnet manager, you can configure one on the host. iWarp Chelsea has those. You can, it uses actually, because it uses TCP/IP, it needs a port number. So we have a registered port number for iWarp, for SMB Direct there, which is 5445, which first of all looks like 445, and second of all is symmetric, so we love that number, right? And you need to enable that firewall rule to allow that traffic, okay? There's a little quirk on the iWarp side. And if you want to route it, iWarp, one of the interesting things is that you can actually do routable RDMA. But by default, we don't route because we like to keep things in the data center. But if you have the right use case to actually route RDMA, you need to set that network direct across IP subnets setting. Yes? No, in terms of comparing iWarp with Rocky, performance numbers, latency numbers, they're all very low. The fact that you're using Ethernet versus TCP/IP doesn't matter that much. It's all implemented in the silicon. It's all in the machine, in the stack of the NICs itself. So they optimize like crazy. They're all few microsecond latency, and they all perform really well. Rocky does have that thing that we talked about using a solution that isn't based on a protocol that can tolerate loss. So Rocky assumes lossless Ethernet. So you have to configure priority flow control in the switch and in the host. So I have some details here on what to do it. It's a minor annoyance. Once you get it done, it will be fine. Now, do not, I repeat, do not deploy Rocky without PFC. Right? The same way that I say do not deploy FCOE without PFC. So this uses raw Ethernet. You need to deploy the solution. You need a switch that does that. On the bright side, most switches these days do support DCB and PFC, which is what's required here. All right, performance. So a few interesting things to talk about SMB Direct and SMB Multichannel over time. We started back in the 2012 developer preview, effectively in 2011, and we showed this comparison of traditional 10 gig versus 10 gig, versus RDMA-based networking, and we had some very interesting results, right? So at the time with the system we had, we were doing line rate at 10 gig non-RDMA, so we disable RDMA on that machine, and we were able to do 2,000 something 512K IOPS using around 10% of the CPU. Then we switch to RDMA, and you see that we're doing 54 gigabits a second, so we're doing way more I/O, but the CPU utilization dropping to half. Right? So that's the kind of effect that you see when you switch to RDMA. You can do more work and you use less CPU, right? And also talking about here, we're doing less than 100,000 8K IOPS using 21% of the CPU. And then the fun thing here is when you look at this, it doesn't seem like there's any bottleneck because we're not hitting the line rate, we're not hitting CPU, it's just a heavy stack and how things flow. And I switch to RDMA, then I pass 300,000 IOPS, and then I'm using much more of the CPU, meaning in that case, I'm doing way more work, and I'm not bound by any specific thing. In this case, I was bound by my storage subsystem in that system, in that machine. So very interesting numbers. You can spend a lot of time analyzing that. That was our first introduction to RDMA. Since then, we went to dual RDMA, so 2 NICs with RDMA at the same time, a whole lot of storage. The biggest challenge is finding storage that would keep up with that amount of bandwidth. And we showed that we achieved 10 gigabytes per second with extremely low CPU utilization, very low latency. And we then did three at the same time. And we got this crazy number, 16.7 gigabytes a second. I'm not sure if it's even registering in your mind what that means, right? That's like a whole lot of 10 gigs put together. Each 10 gig can do 1 point something gigabytes. We're doing 16. Doing 500,000 IOPS over that, and using only 65% of the CPU while doing that, right? And latency below 1 millisecond all the while, right? Crazy, crazy numbers. And the latest numbers I got in last year's TechEd was doing 600,000 IOPS at 8K, and again, 16 point something. I mean, you can't go any faster than that. In fact, I have a little fun anecdotes that I like to mention, right? Jose, have you tried with 4 NICs, right? Because why not? The problem we had there is that we couldn't go much faster than this with 4 NICs. You know why? No, it wasn't disk. We actually got a lot of stuff behind that thing, but the problem is the speed of memory. So there is a speed of how fast you can transfer data on the memory of these systems, and we hit that number. That's about 18 gigabytes a second. So we welcome PCIe 4, Gen 4, right, to go over. Honestly, these numbers are crazy. I think most people that talk to me want 100,000, 200,000 IOPS on a system. Most people are not going to put 48 SSDs behind 6 SAS HBAs to achieve these numbers, right? But we do have a study that we published recently, recently meaning 2 days ago, that the Hyper-V team did this very interesting configuration with 2 Hyper-V servers with 2 NICs connected to 2 file servers with 2 NICs each, and 4 SAS controllers going to one of those JBODs that we talked about. And then they did the whole measurement, and they published a white paper, which I welcome you to go and take a look. I tweeted about it yesterday, and you can get the slides later, and it will have the link there. But what they did was very interesting. They achieved consistently over 1 million IOPS, both locally with CSV and over SMB. And I'll let it sink. They have those machines directly connected to this JBOD. So they were able to do 1 million IOPS here. Then they tried it from here, and they did 1 million IOPS there. So those are the 2 bars, right? Sorry. This is local, this is local, this is remote. So it's the same thing. That's the promise of RDMA. Remote direct memory access. It's remote, but it feels exactly like it's here, right? And that's the kind of thing that we could only get before with Fiber Channel. They measure on the host running CSV directly attached via SAS to the machine, and then they measured again on the remote, going from over the network to the server to SAS, going down, right? So that's an interesting data point. I don't think people are going to be deploying tons of million IOPS setups. That's not the point. The point is it's a technology that's keeping up with the hardware, and it's giving you the highest possible performance that you can achieve, right? And this was only 2 nodes. We scale well up to 8 nodes. We proved that already. A few things to talk about here. When we're building these solutions, and this was also a test for me to see how many boxes I can put in a single PowerPoint, right? The notion here is that we're trying to describe to you how you build these systems, right? You have several options. You can go to an OEM and buy these end-to-end solutions, or you can build them yourself, and it's whatever you're comfortable with. We're grateful for the support from Dell to give us these end-to-end configurations. Just announced this week also that Dell now supports the 60 bay JBODs, so in these configurations here, when you have JBODs, we can actually have 3 or even more JBODs of 60 disks each. So that gives me lots of room to grow, right? Typically, we front-end that with 2, sometimes 3 or 4 file servers. And we have SAS going back between the file servers and the JBODs. And then over here, we have NICs, regular NICs that I use for my client access and management. And then I have these special RDMA NICs that are used only for communication between the Hyper-V hosts and the file server cluster. Jose, why do you have everything doubled? Well, because I'm in the file server and clustering team. So I have my file server side and I have my clustering side. And the clustering is all about high availability. It's all about having multiple paths, multiple instances of everything. So if anything here doesn't show twice, it's a mistake, right? Because something can always fail and will survive that failure. That make sense? The other thing that I get asked a lot is, first of all, could you put more boxes in that diagram, right? And say, yes, of course. And the other thing is, how do you think about performance? People say, hey, I had a performance problem here. Can you help me? And say, yes, here's a questionnaire, right? Because performance in this system only matters when you're thinking end-to-end. So you have to look from the client over there that's running a web, a browser, that's talking to a web server that's in a virtual machine, that is accessing SMB and going over here to grab a few pages that are effectively stored as little blocks in your SAS disks, right? So you have to look at it end-to-end. So how many clients? What's the speed of the client? How many NICs on this side of the Hyper-V host? How many on this side? What's the speed? Are you connecting to the switch? Are you teaming? Are you doing all these different paths in a way that they are compatible with each other? Because if I have 56 gig networking here, but in the back here I have slow SAS, like 3 gig SAS with not enough paths, then I'm not going to be able to transfer all that data. So it's important to keep everything very compatible with each other. So if you have 2 times 56 here in the front, you have to add up to 100 gigs in the back as well, so that you can match and you can go all the way up to the number you intend to get to, right? So these are all the things. We also have details on spaces configuration. How many spaces? How many columns? Jose, what's a column? Well, there's a good talk about storage spaces that you should have watched, right? Columns are how many disks I will engage at once. If you only use one column, your space will only be as fast as one individual disk. You need to have multiple columns to engage multiple disks at once. What's the SAS speed? You know that SAS used to be slower, then it went to 3 gig, to 6 gig per connection, and most of these SAS cables are effectively 4 lanes of 6 gigs these days, so 24 gigabits per second, and we can use multiple of those ports. You have to match all this. By the way, 12 gig SAS is also an interesting technology coming up. The 2 most common configurations that you'll find when you're thinking end-to-end is all converged, no RDMA, and someone might say, Jose, are you saying that we don't need RDMA? It's an option. You don't have to deploy RDMA. You do it if you think you need it, if you need the low CPU utilization, if you need the high throughput. And honestly, in the high end, it will always be available to you. So you could use it, but you don't have to. Imagine if you have only 2 NICs, you can get these 2 NICs team, and then through TCP connect to your SMB server. On the other side, you have 2 NICs teamed, connect to the virtual switch. From the virtual switch, you get a port for your SMB client, and then you get a port for your VM. Perfectly fine configuration. 2 times 10 gig, you get 20 gigs of throughput. Another configuration is with RDMA. Then you have 2 paths. The regular path that we talked about, and then you have like a special path here that goes from 2 RDMA NICs here straight back to the server. Right? So this is all about giving storage that special data center network access. Both solutions are fine. That make sense? Jose, can I team RDMA NICs? No. If you team RDMA NICs, you create a software barrier between the SMB stack and the physical NIC, and we can no longer talk to the hardware to make that work. So if you want to leverage RDMA, SMB must have line of sight to the physical NIC. Okay? Yes? How do you make sure that storage goes over RDMA? SMB knows that. When SMB sees RDMA, it will only use RDMA. So in this configuration, SMB looks at all the NICs and says, oh, true non-RDMA, true RDMA, it will go for the true RDMA naturally. You don't have to do anything. All right, and then to the last portion of the talk. And the notion here is we have played with this technology for a few years now, and we know a few things that people have told us that they run into. And I want to summarize a few of them here. First one is make sure your network interfaces are RSS capable. It's not very common, but I've seen folks that come across NICs that don't report themselves as RDMA capable. And then in that case, we will not do multiple TCP connections, because if they are not RSS capable, then it wouldn't help. Now, sometimes it's a driver that needs updating. Sometimes you're using a desktop class NIC. You should definitely go and use server class NICs with your server hardware. I've seen a lot of folks that use desktops to do lab work, right? And then they run into these NICs. Be careful with that. I have a blog on that. Multiple VNICs on the host. That's an interesting thing. In the case where you're not using RDMA, you only have, say, 2 10 gig NICs teamed connect to the vSwitch. The NIC that you get on the host is what we call a VNIC. So it's a NIC coming off the vSwitch. That is a non-RSS capable VNIC that will limit the performance of SMB. I will actually move back to the diagram to show you what I'm talking about. So in this setup, see this connection here? It is best to have multiple NICs coming off the vSwitch. There is a command to do it. You should, in this setup, have at least 2 VNICs here, if not more. Why? Because I want to make sure that I put traffic on this, and this VNIC here does not report itself as RSS capable. Just a heads up. It's an important tip, okay? Obviously, I have some further details there for you to take a look at. That typically what happens is sometimes you have a 1 gig RSS capable NIC that you use for management, and you run into that VNIC that's not RSS capable, and then SMB, looking at something that's RSS capable and non-RSS capable, prefers the RSS capable one, even if the speed is not the best. Okay? So make sure that you have that covered. More TCP connections from inside the VM. So the NIC inside the VM is RSS capable, so you should expect those added connections from SMB inside the VM. Another one, more connections to the scale-out file server. That's an interesting thing. In 2012, if you had 3 shares going to different nodes of the cluster, the client would go to only 1 node and do all its transactions with that cluster from that single node. And it would be the responsibility of that node to grab information from the other shares from all the nodes and redirect back. In 2012 R2, what we did is now the SMB client, when it looks as a scale-out file server, it said, hey, the shares are in all nodes, but some nodes have better paths to the share. So as we showed here, if you have 3 shares in 3 different nodes, the client will now connect to each node separately for each share. So increasing the automation, spreading things across the cluster to improve performance. However, that means that you're establishing more connections. You're effectively having one set of connections per share going to a cluster, which is a good thing. We can handle hundreds of connections. That's not a big deal. And it will help with your performance. There was a change that happened between 2012 and 2012 R2. That's a common one. If you have a cluster, there is, the way the cluster publishes information about networks requires you to have different subnets. So if you have two networks, two NICs, you might be tempted to put the two NICs in the same subnet. Don't do that. If you have two networks, two NICs coming into clusters, you should configure them as separate subnets. And this commonly happens when people are using the HCP, and it's very convenient to just throw the HCP at everything, and it won't work. If you do that, we'll use only one of them. You get the fault tolerance, but you won't get the aggregated throughput. So if deploying in a cluster, which is what you should be doing anyway, you need a separate subnet for each cluster network, okay? Or else cluster will think it's all a single network. I cannot say that enough. The inbox drivers that come with the NICs, that comes with Windows, are not necessarily the latest. And the firmware that is in the NIC that you bought is very likely not the latest. So that goes for any device, by the way, that you get, but this is especially true for network interfaces and SAS HBAs. Update the firmware, grab the latest firmware from the vendor, update the driver. That will save you a ton of trouble. These are very hard to troubleshoot issues if you're not on the latest firmware and driver. I actually have in my blog pointers to the most common vendors that we work with where they find the latest drivers for them. I cannot stress enough, please do grab the latest firmware and driver for your NICs. That one I demonstrated to you. Sometimes people do a little bit of work on multi-channel and they don't see it in action. Why? Because you need to do some I/O before multi-channel engages. Just mapping a drive to a share doesn't make multi-channel trigger, right? So be aware of that. And also, if something is not being used, the SMB connection will be dropped. So if you access a file, then close the file and don't do anything, after a while, that connection will go away. That's natural. It's a little more common when people are doing testing, because when they deploy this with Hyper-V or SQL, you will see that Hyper-V and SQL will never let go of the files, so you never have that kind of problem. But sometimes when you're doing experimentation, you might run into this one. Question I get a lot, can I use SMB without RDMA? Absolutely. Be free to use even 1 gig NICs. I have a few folks that say, oh, I actually have 6 1 gig NICs on each host and I team them. Can I use RDMA? Can I use this without RDMA, just 1 gigs like that? Absolutely. Know your workload. If your workload calls for that kind of thing, be my guest. You can use with or without RDMA, right? Certain things like live migration work really well with RDMA, much better than with traditional networks. But even that, you can do compression, you can do other things. There are alternatives. If you can, use RDMA. It always works well in terms of CPU utilization and latency, but not every scenario calls for that. Is it possible to run SMB Direct from within a VM? Okay. I have to go slow here because there was something in the keynote yesterday that contradicts this. But with Windows Server, we do not do RDMA from the guest. We only do RDMA from the host, right? So can I do SMB Direct from within a VM? No. There's a special case of a feature in Azure that some folks are doing there. I will, as I mentioned, I'm talking about private cloud, right at the beginning, not public cloud. So with Windows Server 2012 R2, you cannot do RDMA from the VM. Okay. Use client network for CSV traffic. Well, this one, I've run across it a few times, especially for folks that are doing these aggregated clusters. So if I have, say, 3 nodes accessing CSV files, and you're not doing like the storage separated from the compute, it's all together, CSV will actually do redirection between nodes. That was also very common in 2012. And that traffic between nodes, depending on how your network is configured, might not use your best NIC. So if you have, say, 2 RDMA NICs and 2 non-RDMA NICs, and you say the RDMA are for cluster and client access, and the non-RDMA is just for cluster access, the internode communication might not leverage RDMA. Does that make sense? Because you explicitly said these 2 NICs are for folks that come from the outside, and these 2 NICs are the internode communication. There is a setting to tell CSV to say, if you're redirecting, it's okay to use the client access network. And if that one is RDMA capable, definitely you want to know about that. If you're using the disaggregated model, right, where the compute is there and the storage is here, and you're using 2012 R2, we actually never do redirection. We go straight to the node that has the access. We pretty much eliminate any redirection in the cluster. But if you're using 2012, there's a possibility of doing redirection. And when you're doing compute and storage together in the same cluster, there's potential for having redirection. So you should definitely watch out for this setting. Not on by default, by the way. Single file copy performance. Yes. We had a few issues in the RTM release of 2012 R2 where you couldn't do file copies faster than a certain throughput, right? And that relates to how file copies are done. And honestly, file copies are really not a good way to measure performance. I know we have this great little thing that we put visually in front of you when you do file copies now, right? This new dialog when you're doing copies that has a little chart that shows performance. That's awesome. But the problem is copies have so many different dependencies, right? You're measuring the performance of the source and the destination. So if you're copying from a slow source, you're just as fast as that source. The other thing is copy is a sequential write operation, which is really not the best mix of workloads. So typical workloads are much more read-heavy than that. So you're imposing pretty much the worst case scenario in terms of performance is all writes when you're going to that destination. The other thing is we're doing a lot of metadata operations. So when you're copying, you would think if you're copying a 1 gigabyte file that you create the file with 1 gigabyte, then fill in the blanks, right? That's not how we copy. The way we copy is we create a file that's empty. Then we grow the file, copy a little bit. Grow the file, copy a little bit. Grow the file, copy a little bit. And we do that multiple times. So this perfect storm doesn't work really well with the RTM version of 2012. With the update, the latest, the GA patch that came later, we fixed that. And we're essentially for this, we're doing larger chunks now, which optimizes things a bit. But still, if you want to measure performance, run your workload or run a simulation of a workload. If your workload is copy, that's fine. But if your workload is Hyper-V, run Hyper-V and test with Hyper-V. Copy has too many variables involved. It's kind of hard to get it right. And that was it. I'm sorry for the dense content. I really was trying here to kind of give you all the details about networking in a good reference talk that you could go back later, take a look, and see how things work and evolved over time. I was trying to give you a good glimpse of performance, configuration, but also include the basics. I hope that wasn't too fast or too cursory in certain areas, but I welcome your questions. We have 5 seconds left. Yes?
Why you cannot mix Hyper-V roles and scale out file servers roles with the same hardware?
The question is disaggregated versus aggregated, right? That's a common question. We opted for the disaggregated model as our recommended configuration because, in a sense, by doing that, we can scale better, right? If you look at how that SaaS infrastructure works, we have limits on how much SaaS storage we can deploy on a given machine. So the typical configuration of JBODs won't allow more than 4, sometimes 6 or 8 ports to connect, and that would limit our scalability, right? And we thought that it would be more interesting to have a storage layer separate from the compute layer. The other thing, we talk about these redirection scenarios. When you start growing these clusters of storage, you start to have a lot of redirection between nodes. It is a cleaner story when you have the storage side here, the compute side here, and the compute nodes hit exactly the best possible path for accessing your storage. And in general, that works well with also how people think about deployments. Current solutions based on SAN or NAS devices establish this separation between compute and storage, and we're following that model. For scalability, it's great. I can have 32, 64 node clusters connected to the storage, and there's no limitation in terms of how SaaS hardware works, right? That makes sense? If you're doing fiber channel deployments or iSCSI deployments, things might be a little different, but I'm focusing on this SaaS-based solution with storage spaces, so you can do up to 240 physical disks connected to a file server cluster and then extend that further. Typical configurations will go to dozens of compute nodes, no problem, because you're going over the network. Not sure if that makes sense. No, the million IOPS demo, the question, was a 2-node file server, 2 Hyper-Vs, and they were using both at the same time to achieve 1 million. We did. A question is, could you do better if you had 8 nodes or more? Yes, absolutely. We proved that we scale out really well. You just have to respect that rule about having a system that in every layer is harmonious, right? That you have bandwidth on the network, bandwidth on the SaaS side, and all that. If you can measure all that and it's all compatible with each other, then it's great. You can scale out really high. Last question. Go for it. Yes, in the cluster, when you have multiple NICs, you really do want to have them in separate subnets. It doesn't have to be IPv6 or IPv4. We equally support V4 and V6. It could be 2 separate V6 networks as well. Cool. Thank you guys so much.